Question 1. Evaluate correct to 3 decimal places cos 17 degrees. We'll just press this through our calculator. We'll press cos 17 and then equals. That'll give us a decimal. That's the long decimal you'll get there, and we need to round it to 3 decimal places. We'll chop it after the 6 and check whether the 3 is 5 or more. It's not, so we don't have to raise the score at all. So 0.956 is cos 17 degrees to 3 decimal places. Question 2. Find the acute angle theta correct to the nearest degree if tan theta equals 1.732. Into our calculator, because we're finding a degree, an angle, we'll have to press Shift tan 1.732, then equals. That gives us a final answer of 60 degrees if we round it to the nearest degree. 60 degrees. Question 3. Round to the nearest degree, 36 degrees 12 minutes. When we want to round to the nearest degree, 36 degrees 12 minutes, we have to focus on the 12 minutes. We have to recognize that that minutes section is out of 60 minutes, and each 60 minutes rounds up to 1 whole degree. But unless 12 minutes is past halfway, or 30 minutes there, that's less than halfway, so the 36 will stay the same. The 36 degrees will stay the same because 12 is not 30 or more. We usually use 5 or more raise the score as a bit of a saying for rounding up decimals, but that's because halfway is 5 out of 10. But here it's 30 or more raise the score. And because 12 minutes isn't more than halfway, we just keep the 36 the same. So 36 degrees, 12 minutes rounded off to the nearest degree is just 36 degrees. Question 4. Find y correct to 1 decimal place. We've got to decide in these questions whether it's a sine, cos or tan question. From the angle of 57 degrees, this question involves an opposite side and a hypotenuse. So I'm going to have sine theta equals opposite over hypotenuse as the basis of my setting out here. Because it's an opposite and a hypotenuse type question, it's a sine type question. So sine theta equals opposite over hypotenuse. In the opposite position from the 57 degrees we have y, and we have 9 in the hypotenuse position here. So we're going to have sine 57 degrees equals y from the opposite over 9 for the hypotenuse. So we're just filling in the appropriate numbers in that second line down. Now we want to get y on its own, so we want to move the 9 that's dividing at the moment by doing the opposite to both sides. So we'll multiply by 9 both sides, which lets us get y on its own in the end. We did swap sides there sneakily, but we'll have 9 times sine 57 degrees. So that was to get y on its own, and we'll type that into our calculator. And we'll get a value for y as 7.5, and that was rounded off to 1 decimal place. So we used the sine equals opposite over hypotenuse set up there to get everything in the right place, and then we just solved it to get the letter on its own. Question 5. Find n correct to 1 decimal place from the diagram below. So from the 18 degrees, this question involves an adjacent where the n is and a hypotenuse where the 11 is. So we're going to make the basis of our question cos theta equals adjacent over hypotenuse. So cos of 18 degrees equals whatever's in the adjacent position, in this case n, over whatever's in the hypotenuse position, which is 11 in this case. So to get the letter on its own, we need to multiply both sides by 11, because 11 is dividing into the n at the moment. So we'll multiply both sides by 11. We'll kind of switch sides as well. N will be on its own when we multiply by 11. And the other side ends up being 11 times cos 18, which we can process through our calculator, and we get to one decimal place an n value of 10.5, which makes sense because it's a shorter side we're finding it, and we should get an answer that's less than 11. Question 6. Find P in the diagram below, correct to one decimal place. Okay, from the 60 degrees we have in this question an opposite where P is and a hypotenuse where the 32 is. So we'll base our question on sine theta equals opposite over hypotenuse. When we stick to that order for this question, we get sine of the angle, which is 60 degrees, equals opposite, which is P, and hypotenuse, which is 32. Next step is to get P on its own. We'll need to move that 32 that's dividing by multiplying both sides by 32. That will cancel out from the letter side, leaving us just with P. We'll swap sides in the same breath here. And on the other side we'll get 32 lots of sine 60. Throw that into our calculator, we'll get P equaling 27.7, which was rounded off to one decimal place. We were expecting a number that's definitely less than the hypotenuse of 32, because the hypotenuse is supposed to be the longest side. So that fills us with confidence that we've done everything correctly there. Question 7. Find theta correct to the nearest degree. Now when we find an angle, we have to remember to press shift at some stage in the question. From the angle of theta there, we have this diagram, and it involves an opposite side where 21 is and a hypotenuse where 29.6 is. So the trigonometry ratio that involves opposite and hypotenuse is sine. So sine theta is equal to opposite, in this case 21, over hypotenuse, which has 29.6 in it at the moment. So sine theta equals 21 over 29.6. Now carefully here we have to remember to press shift. We'll press shift sine, and in brackets we'll put a fraction in, 21 over 29.6. We'll have another bracket and then press equals. So unless you remember to press shift in this process when you're finding an angle, you'll get a strange answer, usually an extremely small angle of 0 degrees something or other, and that's a little bit of a warning sign that you've forgotten to press shift if you get a ridiculously small angle as your answer. So it should be a decent size angle for your answer to fill you with confidence. But the important thing, whenever you're finding an angle, press shift at some stage. The answer here, theta equals 45 degrees once we've rounded it to the nearest degree. Question 8. Find theta correct to the nearest degree in the diagram below. When we're finding an angle in these types of questions, we must remember at some stage to press shift. This question, from the theta, we have an adjacent position of 31 and a number in the hypotenuse position, 38.9. So adjacent and hypotenuse, that indicates a trig ratio of cos that we should be using. So we'll just write that out. Cos theta equals adjacent over hypotenuse. Cos theta equals, in this case, 31 that's in the adjacent position and 38.9 that's in the hypotenuse position. Here's where we press shift. cos, and we'll have a fraction of 31 over 38.9, get everything in the right order. We'll have another bracket and then we'll press equals. We're expecting a decent size angle. If you get a 0 type angle, you haven't pressed shift in your process. So we'll run that through the calculator and we should get theta equals 37 degrees once we've rounded to the nearest degree. Question 9. Find theta correct to the nearest degree in the diagram below. Once again, we're finding an angle or theta, so we have to remember to press shift at some stage. From the theta, we have sides of opposite and adjacent in this question if you look carefully. So opposite and adjacent involves the tan ratio. So we'll use the tan ratio for the basis of our solution. Tan theta equals opposite over adjacent, get the order correct here. So tan theta equals 12.3, which is in the opposite position, and over 13.4, which is in the adjacent position. Remember, we're pressing shift in these questions, shift tan. We'll do the fraction carefully in the right order, 12.3 over 13.4. We'll put another bracket and we'll press equals. And we're expecting a decent size answer for our angle here. Theta equals 43 degrees once we've rounded off to the nearest degree. Once again, if you have a 0 type answer, a really small angle for your answer, you've forgotten to press shift. Question 10. Find the value of x correct to 1 decimal place. Righty, here we have a 41 degrees and a 21 and an x. From the 41 degrees, the 21 is in the opposite position and the x is on the longest side, the hypotenuse. So we want to pick a trig statement that involves opposite and hypotenuse, and that is sine. To get things in the right order though, a bit careful on this question. So sine theta equals opposite over hypotenuse. We know we're involving the opposite and hypotenuse sides here, so we better use sine. Sine 41 equals 21 over x. Now it's not usual for the letter to be on the bottom, but I'll show you how we can deal with that. But we have to stick to the order of what the sine ratio arrangements say. Opposite needs to be on top, and in this case the opposite was 21, and the hypotenuse needs to be on the bottom, even if it's a letter and makes it look strange. Okay, the way I deal with these ones, when the letter's on the bottom, I swap places with the left-hand side. The left-hand side is sine 41, so I swap those two over, and I get x equaling 21 over the sine 41. Trust me, you're allowed to do that. I could make two moves solving equations there, but we can just remember in this situation that those two positions can swap, leaving the letter on its own. It's a bit of a handy little shortcut. So it works, trust me. So we'll just type into our calculator 21 divided by or over sine 41. Press equals and we'll get x equaling 32.0 to 1 decimal place. Now, having a look at the arrangements of the original question, was 32 as an answer for x a sensible thing? Now you can see that x was on the hypotenuse, which is meant to be the longest side of the triangle, and we were hoping for a number that's probably larger than the 21, definitely. So 32 makes sense there. If we got an answer that's less than 21, we should check our working very carefully.